Montoya. I work with Beisel Manufacturing. We're the ones who provided the drives for the Salt Lake Community College Administration Building, which we're at now. I'm the assistant general manager. We've been working there for about 10 years. We built a variety of panels, all the way from the 7.5 horsepower to I think our biggest is a 60 or so horsepower panel wall, but they're all the same drive manufacturer. So being the size varies, the units themselves are very similar. In fact, almost identical, other than size difference. So on this particular project, we provided a Johnson Controls drive, which is an over-labeled ABB drive. So it's got the ABB looking keypad. The functionality is a lot of the same. But what I'd like to do is go over the components on the exterior of the panel, the components on the interior of the panel, the functionality and the proper way to use it and get information off of the drive. This particular unit, you want to pay attention to on all of the drives, this silver label. The silver label is our rating label. It contains information like the horsepower size, which this is a 7.5, the voltage, which is 460, the amp rating of the breaker of the main disconnect, the trip rating of the disconnect, the frequency rating, as well as the model and serial number, which are important for us to track down, say if you have a problem or need diagnostic issues. The model number will tell us exactly what panel it is, to help you better understand what might be going wrong. And then below that is our ETL rating label. This is just our UL listing label. It basically says that this panel has been built to the same standards that UL requires. This component here on the door, that's the hand interface module for the actual VFD chassis. This is where you do your programming, your displays of your, right now it says 66% of speed, so it's running about a little over half speed. The amp draws in the middle, that's the current load of that the motor's drawn. Right now it's about 3.5 amp current draw. And then the signal below that says 6.66 VDC. And what that is the control signal being sent to the drive. On this particular job, it's a 0 to 10 signal, so anywhere from 0 speed to 10 volts for full speed. Right now it's about 6.85 volts, which is pretty much congruent to 66% of speed, if that makes sense. So those numbers should usually always line up. We have a power on light. This power on light is going to be anytime that main disconnect handle is closed or turned on, that power on light will be there as long as it is getting power into the disconnect. Below that is the VFD run. That light will only activate when the drive is running the motor. And by that I mean just this whole panel running that motor. That light will turn on. Below that is your handoff auto switch. 3-position hand on the left means that you have control of the speed and the start through the keypad. You basically have hand control for using the drive. Off is obviously off and no control. And then auto is the building automation system. The controls guys telling it what to do, how fast to go, and when to stop and start. So you won't have any control if it's in auto through this keypad. Only status and references and stuff like that. You won't actually be able to start and stop it. This light here is a VFD fault light on the bottom right. that indicates a fault with this actual VFD panel. It's sensed something, it's gone into an alarm or a fault, and that light will come on. And typically you'll see on the keypad, if it lights up, it'll give you a code of the fault that it's happened. Say it may be a fault 9. Could mean it's went into an overcurrent. You know, there'll be a fault number for a dedicated condition, essentially. So this will come on when the actual panel faults. The one above it is an external fault, which pertains to a safety. There's 2 terminals in here. I'll show you terminals 1 and 2. That if that opens up due to a safety condition, maybe the static pressure is too high, or a fire alarm type safety, this external fault will illuminate, and that means anything that's external to the panel, like safety, will cause that. Yeah, freestat, stuff like that, you know. Yeah, usually if you see that, what's that?
Dropping a leg?
Yeah, if it drops a phase, like an input phase or something like that, that'll usually go through the VFD fault, because the VFD is actually what senses that fault. Unless there's a phase monitor on here, which I don't think there is, but usually we would hook it up to the VFD. So just know external fault means it's something external to the panel, like safeties or something. And then the other things on the external, on the left side, there's a fan on all the panels. The smaller drives, anything under 25 horsepower will have this 4-inch fan. Anything above 24 or 25 horsepower will have a 10-inch fan. And then on the opposing side, on the top, on the right side, is where the hot air exhausts out of. So yeah, if you notice you're getting weak airflow, you can kind of feel, you know, if you're not getting much airflow. There are filters on these. It's really easy to change on these small ones. This piece just pulls off, and then you've got a washable, like a sponge filter, and it goes on just as easy. It just snaps right on. On the larger fans, you've actually got to open up the panel, and they're attached to the fan on the inside. But there's just some wing nuts you take off your finger. You can rinse it out, let it dry, and then put it right back in. Any questions on the next
Well,
one?
what I see mostly now, when you put these in hand, they go to 60 hertz.
Yeah.
Well, some of them are like other drives around where you can put them bypass button on the drive bypass. Once you can dial it in where that you want it. Where I noticed these don't have that.
Yeah, there's no bypass or like a potentiometer switch on here, so you can dial it in. But I'll show you how to run it in hand, how you can speed it up and speed it down to your desired. You know, you just control that by this essentially versus a speed pot. But there is no bypass on these, so if the drive goes, you know, you wouldn't be able to put it in a bypass and just run that motor full speed. So I guess maybe they didn't have that in the specifications for whatever reason. But this time, I guess if there's any more questions on the external, I'll open it up and show you guys the internal. No sense in getting in there, but we can just look from here, essentially. Grab my flashlight. Okay, so the interior, this is the back of the door. You can see where the handle disconnect is. The shaft enters here, and then that's how you switch the main power off. These are all the wiring of the lights and the 3-position switch here. And it's all spelled out on the diagram that we keep in each panel. These ones are actually on the, These are actually on the inside. They're just sitting there. It's kind of dusty now, but all the wiring schematic of it is in each panel. So I'll start on the left. This unit, this is actually the VFD chassis. You notice it says Johnson Controls up there on the left. But it's an APV drive essentially that's been specifically built for Johnson Controls and York. This This is basically the same comparable model as a AC H550 ABB drive, you know, if you ever need to reference that. So that's the main brain of it. That's what controls the motor. That's what senses the faults and all that. To the left of that, towards the top, these are the terminal strips for connecting the customer terminations, like the controls. They're 9 and 10. That's where they speed up the drive. They've got some controls right here to where they can do some jumpering to control it. The yellow wires are statuses, so open and close depending on what status they want. And then 1 and 2 is the safety, and 3 and 4 is the start and stop. So that's all spelled out on the drawing as well. So if you ever need to access or reference what terminal means what, it's on the drawing. And then to the upper right here, this is the main disconnect. The line side power coming in there, and then the load side coming out the bottom. So it's got a handle mechanism with the direct through the door shaft, so you have direct control of the breaker through the door. And then the relays here, on the first one, on this top is the start relay. It's basically going to be the relay that changes state when it starts or stops. The second relay there should be the external fault relay. That's going to change state anytime you have that external fault condition. And then the third relay should be the VFD fault relay, which is going to change state anytime the VFD goes into fault condition. And then this big black thing right here is the control power transformer. That's just where it gets the 120 power to power the relays and the lights and stuff versus going off the high voltage 460. It basically just converts that down to 120 to run the lights. And then the bottom left, you can see the fan in there as well. That's blowing the positive air in and then exhausting out that top right. But pretty basic stuff. This is a keypad cable, the blue keypad cable that runs that hand interface module. Any questions on the interior? Pretty simple stuff. Well, pretty basic anyway, I should say. There's a little defeater here. I don't suggest you use it much, but you can get into it if you need while it is running. The way to run this, obviously you're not going to be able to run it in auto. So if the building maintenance system ever goes down or you need to take control of it locally, you want to turn it to the off position, let it speed down, do its thing, kind of reset, and then hit it to hand. If you turn that to hand, it doesn't start right away. You've actually got to tell it to start. And how you do that is hit that little green hand symbol, that's your start. So, and to stop it, so you can get the start there, but to stop it, just turn it to off. Hitting that red switch on the keypad that says off doesn't necessarily stop the drive, it just basically says you're turning it from hand to off. So the best way to stop it is actually turn that 3-position switch off. Pretty common practice anyway. But then once you've got it started, you'll see on the top, that'll be your speed that it's running at. If you need to speed that up or down, there's just these up arrows and the down arrows there in the center. So to go faster, you can increase it by hitting the, toggling it up and then toggling the arrows down to slow it down. I think on this project, on the pumps and motors, I think the minimum speed is going to be 15 hertz. Yeah, which is pretty typical. 15, 20 hertz. So you'll never be able to run it slower than that, obviously. But 60 hertz is typically going to be your max, like for your pumps and things like that. There is an air handler here on the west side of the building. Yeah, number 2 air handler that is designed to run above 60 hertz. And I think that's in the 88 hertz, 86 hertz range, somewhere in that area. Yeah, it's just designed to run a little higher than 60 hertz, so I guess it's more efficient that way. But again, If you ever have problems with it or notice that VFD fault comes on, pay special attention to the model number here so we know which drive it is. And then the fault code, most importantly. You know, like I said, it could be a fault 9, could be a fault 6, could be a fault 12. That is easy reference to get what the problem is going to be.
So will we get a cheat sheet of what the code is?
Unfortunately, with ABB, their drive manuals are really extensive and they charge you for them, so they are accessible online, I know.
Are they?
Yeah, so you can either call us or you can go online to find out what the faults are and what they mean, but it's really easy. There's a whole section in here that say, you know, say fault 9, this is the condition, check this, and this,
Yeah.
you know. So.
Because with us right now, what is a 9? You have to be like, okay.
Yeah, who knows?
Yeah, exactly. So if we had we can get that information on the internet.
Yeah.
If we can maybe get it to print off and then maybe put a cheat sheet in each one of them.
Yeah, that's probably not a bad idea. Just go online, print out the fault indications and stuff like that. That way, somebody's got easy access, no matter which guy it is. You know, that's basically it.
Well, it's a lot easier than yeah, that can touch that. So complicated.
Yeah.
It's unbelievable.
Each manufacturer's going to vary.
Yeah.
I work with a number of them, so I learned a little.
Well, these are a lot,
but yeah.
Not simple.
I think these for this job is going to be a really user-friendly unit. Really, so. But they're designed basically just to run automatically. You shouldn't really have to worry about it much aside from cleaning the filter. Yeah, every couple of years it's not a bad idea to go in and tighten the terminals again, because over time, vibration, sometimes things can loosen up. It's not a common problem, but it's one thing I recommend. But yeah, like I said, they're just meant to run and not be have to really worry about them. So. That pretty much concludes my training. Unless you guys have any more questions or
these are like 10 horse.
These ones are 7.5.
Okay, 7.5.
Yeah. So they're pretty small. I think these are the smallest ones we built on this project. But there's some down here in the basement on the east side. There's some in the basement on the west side, and there's some on the roof that control some of the roof units. And then I think there's some in the penthouse floor as well.
Oh yeah.
There's one up there and like a closet as well. But it's pretty basic. I mean, I just wouldn't recommend going in there. Obviously when they're on, there is you could die. There's electrical hazard in there. Unless you know what you're doing, I would definitely recommend having the power disconnected before you get in there and tinker around. So, any other questions you guys think of? At this time, it probably concludes the training for VFDs.